Hi everyone, welcome to this Python crash course. Perhaps you're completely new to computer programming or new to learning Python, and that's perfectly fine. In the next 60 minutes, we'll be learning the most important fundamentals of Python, but in a compact, hands-on, and even fun way. No extras, just the essentials you really need to start writing Python code today. So, what will we be learning? Let's start with what Python is, why everyone likes it so much, and where it's used. From YouTube and Instagram to artificial intelligence and data science. Then we'll jump straight into the code, starting with simple programs like Hello World, how to use variables, data types, and user input. Pause. Before you keep watching, did you know that 83% of our viewers aren't subscribed? That's like eating pizza without cheese. Technically possible, but why would you? Hit subscribe or we'll keep making up statistics. We will also learn how to do mathematical operations in Python, make decisions with if-else, and repeat tasks with loops like for and while. You'll learn how to organize your code with functions, handle lists and dictionaries, and even create simple object-oriented programming with classes. We'll even touch on error handling, built-in modules, and conclude with a short hands-on project to bring it all together. By the end of this crash course, you'll have a solid foundation, and you'll be able to write your own Python scripts confidently. Ready? Let's get started with what Python actually is and why it's worth learning. So, what is Python and why are so many people crazy about it? Python is a high-level programming language that's simple, readable, and powerful. Its syntax is English-like, making it a favorite among beginners. But don't be confused. It's also used by experts at the world's biggest tech companies. Python's actually used everywhere. Artificial intelligence and machine learning. TensorFlow and PyTorch are Python-built libraries. Web development. YouTube, Instagram, and even Reddit use Python as a backend. Automation. From automating routine tasks to dealing with files or web scraping. Data science. It's the go-to language for data analysis, data visualization, and building dashboards. And because of this versatility, Python developers are highly sought after. Whether you want to be a data analyst, AI engineer, or a full-stack web developer, Python offers opportunities. Moreover, Python has a huge community and an abundance of free resources. So, when you're stuck, chances are somebody's already posted the solution on the internet. In short, Python is easy to learn, extremely useful, and one of the best skills to learn today. Now that you know why Python is so useful, let's take a look at how we can actually run our first Python code. Idle. Pre-installed. When you install Python from python.org, it comes with something called idle, a simple editor where you can run Python code. It's great for beginners. Online editors. Don't feel like installing anything? Use online editors like replit.com or Google Colab. Just visit colab.research.google.com, hit New Notebook, and you're ready to code in the browser. VS Code for long-time use. Install Visual Studio Code and the Python extensions, and you'll get autocomplete, syntax highlighting, and an awesome developer experience. In any of these editors, type this: print, open parentheses, quotes, hello, comma, world, exclamation point, end quotes, closing parentheses. Hit run and boom. Python will print your first message to the screen. Now, you're officially a Python programmer. Next up, let's understand variables and how Python stores information. Alright, now let's move on to the Python fundamentals. Let's talk about variables, data types, and two very important functions, print and input. Variables, what are they? Think of a variable as a labeled box where you can store something. You give it a name, and Python will remember what goes into it. For example, here we have assigned the variable name as Alex. Now, we've stored the string Alex in a box labeled name. Do you want to see what's inside? Use print, and Python will respond with the string Alex. Think of your phone book. You save a number with a name like Mom. When you call Mom, it dials the number, even though the phone recognizes the actual digits. That's how variables work in Python. Now, let's learn about data types. Python supports different data types, just like your fridge has different containers, juice, egg, and vegetables. These are the 4 basic ones. Int, integers, like 5, 99, whole positive numbers. Float, decimal numbers, 3.14, 75.5. str, your text strings, like hello or Python. Bool, Boolean, true or false, like yes or no switches. In the code section provided, we have assigned variable age as integer value 25, height with float value 5.9, name with string Alex, and is_student with Boolean value true. Now, let's move on to those 2 important functions we talked about at the start of this section, print and input. Say hello to the print function first. It's how Python communicates, displaying output. Suppose you have a name stored in a variable and you call the print function with it. Python shows you a message like, your name is Alex. That's Python combining text with a stored value on the screen. Think of the print function as Python speaking out loud. Now, let's learn about input. This one lets Python ask you a question. When Python uses the input function with a question like, what city do you live in? It waits for your response. If you type London, Python stores that answer. Then it might respond, great, I've heard London is amazing. That's the input function capturing your response and the print function displaying it with a friendly message. Let's create a simple mini program. Python first asks for your name, then it asks for your age. Finally, it returns something like, hi Alex, you are 21 years old. Behind the scenes, it's processing what you typed and returning a response. Just like a chatbot, it listens and responds. And voila, you just coded your very first interactive program with just 2 tools: input function to get answers and a print function to respond. Easy, right? Now, let's have a small recap of this section. Variables are like labeled containers. Data types are types of data. Print is how Python speaks. Input is how Python listens. Section complete. Next, let's see how Python makes decisions with operators and expressions. All right, let's talk about one of the most used tools in Python, operators and expressions. Operators are like tools in your toolbox. They help you do things. Math, comparing, making decisions. Let's break them down. Arithmetic operators. These are your basic math tools. Plus for addition, minus for subtraction, star for multiplication, / for division, % for remainder. We call it modulo. Let's look at the code example. Let's say you're dividing 10 chocolates among 3 friends. The division gives you each person's fair share, which is 3.33. The percent tells you how many are left over after everyone gets equal pieces, which is 1. Comparison operators. Used to compare values and return true or false. It's like asking yes or no questions. Double equals means is equal to. Not equals means is not equal. Less than, greater than, less than or equal to, or greater than or equal to. In the given code, the variable marks is used for comparing grades. It first checks whether marks is higher than 90, and that gives false because the value is 85. In the next line, it checks whether marks equals 85, and that gives true because the value inside marks is actually 85. You're basically asking, Is this mark good enough for an A grade? And Python answers you, yes or no. Logical operators. Now let's get smarter with decision making using logical operators. And means both conditions must be true. Or at least one condition must be true. And not negates the result. True equals false and false equals true. In the provided code, 2 tests are performed to determine if someone can enter the movie. The age variable is set to 18, and the has_ticket variable is set to true. The print test checks if age is greater than 18 and has ticket equals true. In this case, both are true, so the result is true, which means entry is allowed. If either condition were false, then entry would be denied. Imagine you're checking if someone can enter a movie. The condition looks at 2 things. Are they older than 18? Do they have a ticket? Now, here's the key. Even if only one of those is true, Python says true with or. It's like saying if they're of age or they have a ticket, let them in. The or means only one condition needs to be true. Now, bring in not. This one flips the result. If you're not hungry and Python checks the statement, it says true. Because, yes, it's true that you're not hungry. Think of not as adding the word opposite. So if something is false, not makes it true. And if something is true, not makes it false. Here's a logic summary. Or means either one is enough. And not means flip the answer. Now, let's have a real-life analogy wrap-up to make things clear. Suppose you're making a cake. You're measuring ingredients, so you use arithmetic, plus and multiply. You're checking if you have enough flour, so you use comparison. You're deciding if you can bake now or later, so you use logical and or. Whenever Python evaluates an expression, it just follows these tools to give you a result, step by step. Arithmetic for doing math, comparison for asking questions, and logical for making decisions. Play with them in code and combine them. That's when the fun begins. Now, let's move on to control statements. If, else if, and else. Okay, we know how to use expressions. So next, we're going to learn how to make decisions in code with control flow. Think of this as teaching your code how to think logically and respond based on what happens. The same way you do in life. If, else if, and else, the basics we use in Python. If, to check a condition. Else if, to check other conditions if the first one fails. And else, to handle everything else. It's like planning your day, just like in code. The variable weather is initially set to rainy. Then the program checks if it's sunny. It's not because it's rainy. Next, it checks if the weather is cloudy through an else if statement. Again, this is false. Since neither condition is true, the program gets to the final else block. That's where the code runs, because none of the previous conditions were met. Let's look at a real-life example, a grading system. Calculating grades from marks. Here's the logic. 90 and above is an A, 80 to 89, B, 70 to 79, C, and a below 70 is an F. Let's put this code into logic. We start by setting a variable called marks to 85. The program first checks if marks is greater than or equal to 90. This is false, so grade A is not assigned. Next, it checks if marks is greater than or equal to 80. This is true, so it prints grade B. Since one condition has already been met, the rest are skipped. This means grade C and grade F conditions aren't even tested. Only the first true condition runs. That's how if, else works. Here's what's happening. Python checks if marks is greater than or equal to 90. Nope. Then it checks marks is greater than or equal to 80. Yes. So it prints grade B and stops checking the rest. Now, let's talk about nested conditions. Imagine that grading depends not only on marks, but also on attendance. You pass only if marks are 70 and above and attendance is 75% or better. That's a job for nested conditions, when one condition depends on another. Let's walk through what the code in the slide is doing. We set two variables. Marks is set to 75, attendance is set to 80. The program first checks if marks is 70 or more. It is, so it enters that block. Inside that block, it checks something else. Is attendance 75 or more? That's also true, so it prints, you passed. If either of those conditions had failed, if marks was less than 70, it would print, you failed due to poor marks. If attendance was below 75, it would print, you failed due to poor attendance. See that? One if inside another, layering conditions. First we ask, did you score enough? Then we ask, did you attend enough? This is exactly how schools and systems make decisions. Control flow is everywhere. Think of if, and else as your decision-making engine. It powers login systems checking password matches, games checking player health and currency, shopping carts applying discounts when cart total exceeds a threshold. It's simple, readable, and incredibly powerful. Here's a quick recap. If runs when the condition is true. Else if is a backup check. Else runs when nothing else matches. You can nest them to create layered decisions. That's how your code learns to think, using control flow. Now, let's make things even more interactive. Let's move on to loop statements. All right, now that your code can make choices with if-else, let's take it further. Let's teach it how to repeat actions with loops. But what are loops? A loop lets you repeat the same piece of code over and over until a condition is met or a list is finished. Imagine you're clapping your hands 5 times. You wouldn't type print clap 5 times by hand, would you? You'd loop it. A for loop is used to iterate over items. A for loop is perfect when you know you're doing something a specific number of times. Let's go through a list of fruits. We have a list called fruits that contains 3 elements: apple, banana, and cherry. The for loop goes through each element of the list one by one. It takes each fruit and puts it in the variable fruit. Inside the loop, the program prints, I like, and then the current fruit. Here, Python takes each fruit individually and runs the code block below. You can also use range to iterate a specific number of times. Let's break down this line of code. The range 1, 6 function creates numbers from 1 to 5. It doesn't include 6. So it creates 1, 2, 3, 4, and 5. The for loop iterates over each of those numbers individually and assigns the current number to the variable I. Inside the loop, it prints count with the value of I. A while loop runs as long as the condition is true. A while loop is useful when you don't know exactly how many times something will repeat, like waiting for the rain to stop. It continues running as long as condition is true. Let's look at an example. We first initialize a variable called count to 5. Then the while loop checks if count is greater than 0. If it is, the loop runs. Inside the loop, it prints countdown, followed by the current count. Next, it decreases the variable count by 1. This repeats. Print the number, decrease by 1, then check the condition again. When count reaches 0, the condition count greater than 0 becomes false, and the loop ends. In short, a while loop executes code while a condition is true. Great when you don't know how many times something will happen. If you don't change the condition, the loop runs forever. Break is used to end the loop. The loop starts counting numbers, but when the number is 5, break immediately ends the entire loop. Numbers below 5 are processed individually. It's used when you want to end the loop early once a specific condition is met. Continue is used to skip the current step. This loop runs through numbers from 1 to 5. When the number is 3, continue makes Python skip that iteration. It doesn't print 3, but continues with the loop. All numbers except 3 are processed. It's handy when you need to skip certain values but keep looping. Pass is used to do nothing, a placeholder. This loop runs, but there's nothing inside it yet. The pass is a placeholder, like saying, I'll add the actual code here later. The loop runs without error, even though there's no logic inside of it. Very useful when coding the structure first and adding details later. Let's have 2 simple projects. Simple project 1, sum of first n numbers. A simple program to sum numbers 1 through 100. We set total equal to 0. Then we run a for loop from 1 to 100. Inside the loop, we add I to total. After the loop finishes, we print the final sum. It's great practice with loops and addition. Simple project 2, countdown timer. A program using while loop. It starts at seconds equals 5. The while loop checks if seconds is greater than 0. If it is, it prints the countdown and subtracts 1. When it reaches 0, it prints time's up. A perfect example of how while loops repeat as long as a condition is true. Now, for a small recap of this section. 4. Loop over items or range. While, loop while a condition holds. Break, break out of the loop early. Continue, skip to the next iteration. And pass, does nothing, placeholder for now. Loops are everywhere in programming. Animations, game logic, web scraping, file processing. And now, you know how to use them. Now that we understand how to write loops and logic, it's time to explore one of Python's superpowers, data structures. They're like different types of containers that you can use to store and organize your data. Let's learn 4 of the most common ones. Think of them like different boxes you use for organizing things at home. Lists are ordered and mutable. Think of them like a shopping list. Items are in sequence, and you can add to the end, remove from the end, or insert in between. Here's how it works with a shopping list. We begin with a shopping list containing milk, bread, and eggs. We then use the append function to add butter to the end of the list. We next use the pop function to remove the last item, which is butter. We then use the print function with groceries 1 to print the item at index 1, which is bread. Lists allow you to store elements, add them, remove them, and access them quickly using simple commands. Here's the key points. Maintains order, you can change it, mutable. Index starts at 0. Tuples are unchangeable and fixed. Once created, they cannot be changed. In this code, we define a tuple named dimensions with 2 values. You can retrieve items like dimensions 0, which outputs 1920. However, if you change a value, such as setting dimension 0 to 1280, it raises an error. That's because tuples are immutable. Once you create them, you cannot modify them. It's like a sealed package. The contents are fixed. Sets have no duplicates, no order. Think of them like a basket that automatically removes duplicates and doesn't care about order. We create a set numbers. 1, 2, 2, 3, 4, 4. Even though we included duplicates, the set automatically keeps only unique values, 1, 2, 3, and 4. Next, we use the add function to add the number 5. Sets eliminate duplicates and don't care about order, like a basket that keeps only 1 of each item. It's best for removing duplicates and fast membership checking. Dictionaries are key-value pairs. A dictionary is like a real dictionary. Each word, key, maps to a meaning, value. In the code shown, we create a dictionary called student with keys like name, age, and grade. You can get a value by its key. For example, student brackets name returns Alex. You can even change a value, like setting age to 22. A dictionary stores data in key-value pairs, just like a dictionary where a word, key, has its meaning, value. You look things up quickly using keys like name. Here are some methods that work on multiple structures. Append, add item to list. Pop, remove last item from list. Index, find position of an item in list or tuple. Len, get count of items. Len works on all, list, tuple, set, dictionary, and tells you how many items there are. Now it's time for a small section recap. Imagine these like different containers. List, shopping list, ordered and editable. Tuple, a gift in a box. Ordered, can't change. Set, basket of fruit, no duplicates, unordered. Dictionary, a phone book. Name as key, phone number as value. Some data structure use cases. Unique email IDs use sets. Config settings like width, height use tuples. Student records, name and marks use dictionaries. A playlist of songs uses lists. Master these 4 and you'll handle 80% of real-world Python data with confidence. Great. Let's explore one of Python's fundamental building blocks, functions. They help you organize, reuse, and clean up your code, like recipes in a cookbook. What is a function? A function is a block of code with a name that performs a specific task. You create it once and then call it as many times as you want. Now, it's time for defining and calling functions. Here's how we define a basic function in Python. Use the keyword def and then write the statement inside that function that you want to execute, following proper indentation. And to call it, just use the function name with appropriate parameters, as shown on the slide. Def is short for define. It tells Python, hey, I'm defining a function. Now, let's take a look at features that make functions powerful. First, functions with parameters. You can make your functions receive input through parameters, like ingredients in a recipe. In the first code example, we define a function greet name that accepts a parameter called name. When we call greet Alex, it prints, hello, Alex. Second, default parameters. You can set default values for parameters, so they're optional. This is handy when you want the function to work even without input. In the second example, we define function greet with parameter name equals guest. That has a default value. If no name is given, it uses guest. Greet prints welcome guest, while greet Tom prints welcome Tom. And lastly, return values. You can also return a value from a function using the return keyword. The return sends the result back to where the function was called. In the last example, function add with parameters a and b returns the sum of the two numbers. When called with add 53, it returns 8, which is stored in result. Now, let's talk about where variables live. This is called scope. Local scope variables defined inside a function exist only there. In the function show, the variable x equals 10 exists only within that function. Trying to print x outside the function causes an error. Local variables are like private notes. They don't exist once the function completes. Global scope variables, defined outside functions, can be accessed inside, but should be handled carefully if you want to modify them. In this program here, x equals 5 is defined outside the function. Inside update, we use global x to access and modify that same variable. After calling update, x becomes 10. Global variables can be accessed inside functions, but modifying them should be done carefully. Use global only when necessary. In most cases, it's better to keep variables within functions to avoid confusion. Let's compare Python and C++ function handling. Defining a function. Python uses def greet parentheses semicolon, while C++ uses void greet parentheses curly braces. Notice the semicolon and braces? Passing parameters. Python uses def, greet, parentheses, and the parameter, while C++ requires the type, void, greet, parentheses, string, name, end parenthesis. Return values. Python is simple. Return A plus B. In C++, we add a semicolon. Return A plus B, semicolon. One key difference. Semicolons aren't required in Python, but they're mandatory in C++. Also, in Python, indentation defines code blocks, while C++ uses curly braces. These differences show you how clean Python syntax is compared to C++ stricter requirements. Let's build a simple calculator using functions. We have two functions, add and subtract. Both take two numbers as parameters. Add returns their sum, and subtract returns their difference. We then call these functions with 10 and 5 and display the result. Sum as 15 and difference as 5. This mini calculator shows how functions make your code organized, readable, and easy to extend. You can add more operations like multiply or divide anytime. Clean, readable, and reusable. That's the power of functions. Now, let's wrap up this section with a small recap. Def creates a function. Use return to send results back. You can set default values for parameters. Scope determines where variables can be used. Unlike C++, Python functions are cleaner and simpler. Mastering functions will make your code modular, organized, and reusable. And Python makes it super friendly. All right, let's explore something powerful. Modules and built-in functions. They're like pre-built toolboxes in Python. You don't need to build everything from scratch, just plug and play. Python gives you some pretty handy functions that work right out of the box, nothing to install. These are useful for data analysis, debugging, and quick calculations. Here are some helpful built-in Python functions. First, len gives the length of a string or list. For example, len parentheses hello and parentheses returns 5. Second, sum quickly adds all the numbers in a list. So, sum 10, 20, 30 returns 60. Third, sorted returns a new sorted list. For example, sorted 314 returns 134 in order. Lastly, type tells us the type of a variable. Type 42 returns class int, meaning it's an integer. These functions make Python coding fast and efficient. In Python, a module is simply a file that contains useful code, like functions or variables, that we can reuse. To use a module, we need to import it. Let's look at these 3 useful built-in modules. First is the random module. This helps generate random numbers or make random choices, perfect for games, simulations, or creating simple data. For example, you can simulate rolling dice or randomly select a color from a list. Then there's the math module. It provides advanced mathematical functions. You can get the value of pi, round numbers up, or calculate powers like 2 to the power of 3. It's handy when you need precision or scientific calculations. Finally, the time module. It lets your program work with time, like adding pauses or measuring how long something takes. You might use it to make things wait or simulate real-time actions. By importing these modules, Python gives us amazing tools that saves time and makes our programs smarter. Now, let's look at some popular external libraries. Real-world packages that professionals use regularly. These aren't part of Python by default, so you install them using the related command. Let's examine each one. First, numpy, short for numerical Python. This is all about fast math operations, especially on large arrays or matrices. Instead of using slow for loops, NumPy lets you perform operations on entire datasets at once. Ideal for scientific computing and handling big data efficiently. Next is pandas. Think of it like Excel for Python. It makes handling tabular data super easy, like rows and columns, which is perfect for analyzing survey responses, processing CSV files, or cleaning messy data. If you're working with data, pandas will likely be your best friend. Then there's matplotlib, a powerful data visualization library. From simple line graphs and bar charts to scatter plots, matplotlib helps create visualizations that make your data presentable. It's especially useful for identifying trends, patterns, or outliers in data. Next, scikit-learn, Python's go-to machine learning library. It provides ready-to-use tools to build modules that can predict outcomes, classify data, or detect patterns. Whether predicting house prices or detecting spam emails, scikit-learn is great for both beginners and experienced developers. Finally, streamlit, a newer but very powerful library that turns your Python scripts into interactive web apps. Take your data science project and make it clickable and visual with just a few lines of Python. Streamlit is perfect for showcasing machine learning models, dashboards, or quick demos. No web development skills needed. Together, these libraries transform Python from a beginner language into a comprehensive professional toolkit, used for everything from medicine and finance to research and tech startups. Now, let's wrap up this section with a small recap. Use import to bring in built-in or third-party modules. Built-in functions like len, sum, and type are your shortcuts. Popular modules include built-in, random, math, and time, and external, numpy, pandas, matplotlib, scikit-learn, and streamlit. These tools elevate Python from a simple language to a superpower for automation, data science, AI, and more. Let's wrap up our crash course with two essential concepts that make Python stronger and safer to code: object-oriented programming, OOP, and error handling. Both will help you write cleaner, smarter, and more maintainable code. Starting with OOP, object-oriented programming. OOP is a way of organizing your code using objects, just like real life does. Think about a car. A car has properties like color, brand, and speed, behaviors like accelerate or brake. In Python, we define this using a class. Here, we've defined a class called car. When we create a car from this class, Python calls a special method called init. It's like the object's birth certificate. It sets the brand and color of the car, like a red Toyota or blue Honda. In this class, we also define a method called drive. Methods are actions the object can perform. When we call drive, our car outputs something like red Toyota is driving. The key here is self. It refers to the object itself. Every car we create has its own unique color and brand stored inside. So with classes, we go from simple code to real-world objects that can store information and perform actions, like real cars do. Now that we've built our car class, let's use it by creating an object. We create a car object called my_car. Imagine it's a red Tesla. This object is now an instance of the car class. When we call the drive method on it, it prints red Tesla is driving. Just like a real car, it has identity and behavior. Let's quickly review some key object-oriented programming terms. A class is the blueprint, like a blueprint for a car. An object is what you get after building from that blueprint. An actual car you can drive. The init method is like the constructor. It automatically runs when the object is created and sets up initial values, like brand and color. Self refers to the current object. It gives each object knowledge of its own information. A method is simply a function inside the class, something the object can do. Great job! You've now created a custom object, and like real-world objects, it can do useful things. Now, let's talk about making your code crash-proof and safe through error handling. Python uses blocks called try and except. They let us catch errors when things go wrong, instead of letting our program crash with a big red error message. Here's a simple example. Say you're asking the user to enter a number. If they enter 0, you'd normally get a divide by 0 error. But by using a try except block, you can catch that and show a friendly message like, "You can't divide by 0." If they type a word instead of a number, that raises a value error. But we catch it and politely ask them to try again. Here are some common errors to watch for. Value error occurs when the value is the wrong type, like trying to convert hello to a number. Type error happens when you mix up types, like trying to add a string and an integer. Index error occurs when you try to access an item that doesn't exist in a list. By wrapping risky code in try except blocks, we prevent crashes and give users a much better experience. It's like a seatbelt for your program. It doesn't prevent errors from happening, but it keeps them from being dangerous. Let's have a final recap. Use class to define a blueprint. Create objects from that class. Use init to initialize properties. Define methods to specify behaviors. Wrap risky code in try/except. Catch and handle exceptions gracefully. Learn common error types: value error, index error, and type error. Combined, these concepts help you write structured and safe code. Perfect for real-world applications. Let's wrap it all up with a cool mini project. A guess the number game, with a streamlit UI so anyone can play it in their browser. This brings everything together: variables, conditionals, loops, functions, random module, and streamlit for UI. Here's the plan. The program picks a random number between 1 and 100. You, the user, try to guess it. After every guess, the app tells you whether it's too high, too low, or correct. We'll also limit the number of guesses to make it challenging. Step 1. Install Streamlit, our tool for turning Python code into a web app. Just open your terminal and type the command shown. Step 2. Code it. Don't worry, it's simple and fun. Just follow along or reference the slide for the complete code. Finally, step 3. Run the app by typing the run command shown. After it's running, your browser will open a playful interface where you can test your luck and logic. It's a great way to practice Python, user input, conditionals, and get introduced to real web app creation. Let's briefly review the logic of our guess the number game. First, we use random.randint to secretly choose a number between 1 and 100. That's our target. Then, Streamlit's session state comes into play. It keeps track of how many guesses the user has made, even after button presses or refreshes. The user enters their guess in a number input field, and we use simple if-else statements to give feedback: too high, too low, or correct. When the correct number is guessed, a play again button appears, letting the user restart immediately. Here are some ideas to make the game more exciting. Add images or emojis to make feedback more fun. Track how long it takes the user to guess. Store high scores in a file or a database. Show a line chart of all previous guesses using Plotly or matplotlib. Through this project, you've used Python essentials: random numbers, conditionals, functions, loops, and wrapped it all in a clean, interactive UI with Streamlit. Congratulations! You've not only built a Python game, you've deployed it on the web. We're almost done with this crash course. And now we're going to learn one of the most valuable and empowering skills every programmer needs: debugging. The art of finding and fixing your own mistakes. Here's a secret. No matter how good you get, you'll make mistakes. Even experienced developers face them daily. What separates good programmers is knowing how to handle errors when they happen. Let's walk through 3 of the most common errors beginners make and how to fix them. First, indentation errors. Indentation in Python isn't just for readability. It actually defines your code structure. If you forget to indent after a function or loop, Python will throw an indentation error. To fix this, simply ensure lines of code are properly indented. Usually 4 spaces, not tabs. Most editors will do this automatically. Second, variable name errors. This happens when you reference a variable before you've declared it, or when you've misspelled it. For example, referencing score before it's initialized will create a name error. To avoid this, always declare your variables before using them, and be consistent with names. Also, remember, Python is case sensitive. Total underscore score and capital T total underscore capital S score are 2 different variables. Third, type mismatch errors. Yes, Python is dynamically typed, but type still matters. You can't just add a string to a number directly. Doing UR plus 20 will throw a type error. To fix it, you need to convert the number to a string with str parentheses, so Python knows how to combine them. Here's the important mindset. Don't panic when you see red text. Read the error message, understand what it's saying, and locate the problem. With practice, you'll get faster at debugging, and you'll start anticipating problems before they occur. Real progress in programming doesn't come from never making mistakes, but from knowing how to fix them quickly. Let's talk about some quick and effective debugging strategies. First, get comfortable using type. It's simple but incredibly useful. When something feels wrong, check the type of your data. Is it really an integer? Or maybe it's a string in disguise. Just print type and your variable name, and you'll know it. Here's a classic tip. Use print as your flashlight in the dark. Print out your variables, your loop counters, even status flags inside conditionals. For example, if a function isn't giving you the expected output, print the input arguments inside the function. This way, you can see what's actually being passed in. Say you have a function that multiplies 2 numbers. If something going wrong, a quick print of x and y inside the function will usually reveal the issue immediately. Finally, let's put this all together with some rapid-fire debugging tips. Indent carefully. Watch your variable names. Python is case sensitive. Don't mix data types. Use string, integer, or float to convert when needed. Print often, especially in loops or conditionals, to trace your logic flow. Read error messages slowly and carefully. They're not yelling at you. They're pointing you in the right direction. And remember, bugs aren't roadblocks, they're clues. Each one teaches you something. You're not failing, you're debugging. And that's what real developers do. Now, let's move to our final section. And that's a wrap on our Python crash course. Let's use the remaining 2 minutes to review what you've learned, share some great free resources, and create a roadmap for your future. The basics of variables, data types, and expressions. Control flow, if, else if, and else. Loops, for, while, break, and continue. Data structures, list, tuple, set, dictionary. Functions, defining, returning, and default parameters. Modules and built-ins. Random, math, time, plus, pandas, numpy, matplotlib, streamlit, and scikit-learn. Object-oriented programming basics. Class, init, methods, objects. Error handling, try and accept, and common errors. And finally, a mini project. You built a real app using Python tools. Here are some final tips. Practice daily, small projects, and code every day. Never hesitate to ask questions. Everyone starts somewhere. If you're feeling ambitious, try exploring file handling, web development, data analysis, and machine learning. You now have a solid Python foundation. Keep building, keep learning, and most importantly, keep coding. Thanks for joining this Python crash course. Happy coding!